So in the given problem, he has given the equivalent circuit parameters of a transformer and is asking what is the input current when the transformer is operating at rated load with 0.8 power factor lagging. Okay, so in these kind of problems, we know that the equivalent circuit of a transformer, we can do it either all the secondaries will be shifted to primary side, or all the primary circuit parameters will be shifted to the secondary side. So it's better to shift all the secondaries into primary and then do the analysis. So if I see the equivalent circuit of a transformer is having the primary value R1 and the primary reactance JX1, and when you shift the secondary resistance and the secondary reactance, this will become JX2 dash and this is R2 dash, and this is a load, this is a P2 dash, and also it is having the core components, its value is 10K, and also it is having the magnetizing reactance XM. So XM is given as a 1.55. All the values are given. Only thing is he has given X2 and R2. He has not given X2 dash and R2 dash, right? So first you find out R2 dash and X2 dash. Okay, so I'll say that this is a Z2 dash. So Z2 dash is nothing but A square times R2 plus JX2. So what is A? A value is 2400 by 240. So this is 10. When you do the squaring, this will become 10 square. So R is 2 plus J 4.5. So this value is equal to, it was given all in milli ohms, so into 10 power minus 3, so it's value equal to 0.2 plus J 0.45. So this is Z2 dash, this is Z1. Okay, what about V2 dash? V2 dash is nothing but A times V2. This is 10 into 240. This is 2400. Then what about I2? Because now this current will become I2 dash. So first find out I2, then after that I2 dash. So I2 is nothing but the load current. So load current is nothing but the rating of a transformer, 150 into 10 cube by 240 at an angle of cos inverse of 0.8. So this is equal to 625 at an angle of 36 point. This is a current in the secondary side, but I want to shift it to the primary side. So this will become, when you shift it to primary side, it will become I2 dash. This is equal to 1 by A times I2. So this is equal to 62.5 at an angle of minus 36.8. 87 degrees. Now I'll apply KVL here. So this is the supply voltage. I'll take this as a V1. So when I apply KVL like this, V1 is equal to V2 dash plus I2 dash I2 dash into Z1 plus Z2 dash. All the values are known. The only thing that you have to do here is you should consider this as a 2400. The reference is this one. This is 0 degrees and remaining values are same. So this is plus I2 dash is 62.5 at an angle of minus 36.87 into, we just substitute the values of Z1 and Z2 dash. And if you simplify this, you'll get a value 2426.92 at an angle of 0.35 degrees volts. This is V1. If you see the input current, this is an input current, this is I1 I'll take, this is nothing but I2 dash plus I0. I0 is nothing but the current through this, let us say IR, and the current through this is IXM. So in order to find out the input current, in addition to I2 dash, I have to find out I0 as well. So how do you find out I0? If I know V1. So that's why I have calculated V1. So once you know V1, you can find out IR and IXM. Then after that, you just add those two factorially. You will get I0. Once you will get I0 plus I2 dash will become the input current. Okay. So now I'm going to find out IR. So IR is nothing but V1 by 10K. So this is equal to V1 is 2426.92 at an angle of 0.35 divided by 10 into 10 cube. So its value is 0.2427 at an angle of 0.35 degrees amperes. And similarly find out IXM. So IXM is equal to V1 by JXM. So all the values are known. So if you simplify this, you get 1.56 at an angle of minus 89.65 degrees. Now what about I0? I0 is nothing but IR plus IXM. So this is equal to, you will get some value here. Then after that, the input current I1 is equal to I2 dash plus I0. So if you simplify this, you will get a value of 63.65 at an angle of minus 37.86 degrees amperes. So this is the total input current of a transformer at a given loading.